Alright, today we're going to do a lesson on equation of circles. So the two learning objectives for today would be, firstly, how to form an equation of a circle in standard form if you are given a center and a radius. The second is how to find the center and radius of a circle given an equation in general or expanded form. So the second one is something like the reverse of the first. Alright? So the first one is, how do we form an equation of a circle in standard form given a center and radius? Now let's revisit. What does a circle mean? A circle is a set of points in a plane which are of equal distance from the center. So keep in mind this word equal distance. So when I have the center, that every point on the black line, which is the circumference of the circle, will be of equal distance. Alright, so that's why you see the purple line, that's the radius. So the two lines, the radius have to be the same length. Alright. Now, in this diagram, you will notice that there is a circle in purple and there is a line in red. So that is actually the radius of the circle. So based on this diagram, what is the length of the radius for the given diagram? So you can count, right? Okay, so since there are three of them, 3 units there, so it will be 3 units. Now, I have actually moved the radius to another point on the circle, but as we can remember from the earlier slide, right, it will be the same length. Radius cannot change in the circle, all right? So if you have gotten 3 units earlier on, so the length of the radius in this diagram will also be 3 units. So despite me moving it, the length doesn't change, it's still 3 units. Okay, next. Let's have a point called P on the circle itself. I am not going to give you any particular coordinate, just a general one. So I'm just going to call the coordinate as xy. So it lies on the circle, and we're going to think about what is the connection between x, y, and the radius. So let's make a right angle triangle. The height of the triangle is actually y units. Okay, so the upright vertical height is always the y units, right? And the base of the triangle is actually x units. So there is actually a connection that can connect x, y, and the radius of 3 together. And that is in this right angle triangle. You can see, right? We have Pythagoras theorem that it can be applied. And Pythagoras theorem states that a squared plus b squared equals to c squared, where c squared should be the hypotenuse, or which is the longest length. So to link the three sides, right, we can have x squared plus y squared equals to 3 squared, and 3 squared is actually 9. So in other words, the equation of the circle that we saw earlier on with the origin at the 0, 0, which is at the origin, right, is just x squared plus y squared equals to 9. Okay, now let's try a different circle. This time around, we have another circle, and this time we have 5 units. All right, so you can see that the radius is actually 5 units. I am doing something similar. I am moving the radius away onto a point P on the circle. In the same manner, I'm just going to call it xy. So by now, I guess you should be quite good at it. What do you think will be the equation of the circle? Okay, I'm starting from the origin. So we have this triangle here. So using Pythagoras again, we have a squared plus b squared equals to c squared. So that's where we have x squared plus y squared equals to 5 squared. And 5 squared can be expanded to 25. So in other words, the equation of this circle will be x squared plus y squared equals to 25. So these two examples we have all starting from the origin. So let's just start from the origin first. And let's go with a general form. So for this case here, right, you notice that the difference here is I did not give you any units for the radius. So how do we link the three together? It is still exactly the same, all right? So we still can use Pythagoras theorem. So we can have x squared plus y squared equals to r squared. So this is how an equation of a circle will look like if it starts from the origin. But life is not so easy all the time. It doesn't mean that every circle that I have must have the center in the, at the origin, which is 0, 0. So we can have a case where the circle's center is at 2, 1, which is point C. Again, I will just have the radius of 3, and I have a point P, which is xy, on the circle itself. So how are we going to do the how are we going to obtain the equation of the circle? It's the same thing. We can still form another right angle triangle, no difference. And this time around, you have to be a little bit careful with the height of the triangle because we are starting at the point 2, 1. So your center is at 2, 1, right? So if you look at the height of the triangle, I do not know what is my y value, but I know that the height I have to minus 1 because it's the difference between the two. Okay? So that's how I have the height as y minus 1. And the base, whatever x is, I started at x equals to 2. So that difference will be the base of my triangle. So we have y minus 1 for the height and x minus 2 for the base. And the radius is still 3 units because I borrowed this from the first circle that we did. So let's use Pythagoras theorem again. A squared plus b squared equals to c squared. So linking the 3, we have x minus 2 squared plus y minus 1 squared equals to 3 squared. Then we have 3 squared. We can actually expand it to 9. And so the equation now will be x minus 2 squared plus y minus 1 squared equals to 9. Alright, so we have taken note of a new center, but generally the Pythagoras theorem way of linking the 3 will still work. So what is the general form? So in this case here, again, I don't use any particular radius unit. I just call it as r. So it is going to be the same where whatever my center is, alright, I just call it as AB. My height will always be y minus b, alright? So that will be the vertical height. The base of the triangle will be x minus a, whatever a is. So that will be your a squared plus b squared equals to r squared. And this is where we have the standard form of the equation of a circle. Alright, so hopefully this has been quite helpful. Now, what can we do next? Let's practice. Okay, now we have a circle here, and you can see I purposely did not choose the circle with the center at 0, 0. So how can we express the equation of the circle in standard form? Okay, let's just pause and then think about it. Okay, so the first thing that you can do is to think, where is my center? And how much is the radius? So if you look at this question here, right, the center is at 1, 0. And the radius is actually 1. So remember, we take the difference of x and the difference of y, right? So for x, I have x minus 1 squared. For y, I have y minus 0 squared. Radius is 1, so it's 1 squared. So x minus 1 bracket squared plus y squared equals to 1 will be the equation of the circle in standard form. Are we alright? Okay, what if we want to do the reverse? Alright, so if I give you the standard form of an equation of a circle, are you able to figure out what is the center and the radius for each circle? So it will be good for you to take out a piece of paper, pause this, try it out before you continue to play on the video to check the answers. Alright, get started now. Okay, let's review the answers. So these are the answers for all the questions. So be very careful. Some of you may think that you've gotten some of the questions wrong, but I want to put a warning here. Make sure the equation is in the correct order. Don't be tricked. Now, why do I say that? It's because the third and the sixth question, I have purposely swapped the order of x and y. So be very mindful. You have to understand that we always have to start with x minus a bracket squared plus y minus b bracket squared equals to r squared. So sometimes you may have to just change the order so that you can get the a and b accordingly, which is the center of the circle. Alright, so this is going to be the first part where you are able to obtain the equation of a circle and also to figure out what is the center and radius if you are given the equation in the standard form.